Hello, I'm Abhishek Xavier from ADS department. My project is about predictive modeling of stellar properties. So my project is about predicting the properties of stars. Stellar is a star. So introduction is the what are we gonna do with the properties like collapse fate of stars. We are going to determine what the star is going to be when it collapses, and it is determined by its mass of the stars, and this is predicted by the collaboration of sun's mass and the respected star's mass, which is going to be predicted. Then stellar classification is we are going to predict the spectral types of the stars, which indicate their colors and other physical properties, and this is going to be predicted based on the temperatures. And going to estimate the stellar age. We are going to estimate the age of the specific star which we are going to look for, and this is done by temperature and luminosity. We're gonna take a formula like between the temperature and luminosity to estimate the stellar age. And mass radius relationship, we are going to predict the relationship between the star's mass and radius, which provides the structure and evolution of it, which basically describes the structure of the universe and galaxies. This helps in determining the structure of universe and galaxies. And the exoplanet host prediction is we are going to check whether a star can hold a star, or the sun can hold a planets like that the other stars could hold a planet or not. We are going to check the potential of holding a planet of a star. This is done by using the term called metallicity, which is the abundance of iron over the hydrogen. This is the formula for metallicity. We are going to predict using this, and the problems which can be solved by this is we can decide the fate of a star and identify what it might happen when it's end its life, and we can also predict the exoplanets which is going to be hosted by the specific stars which are going looking for, and we can predict the spectral types, and we can see the stars functionality and how the stars behaviors are using the temperature, and we can analyze the age of the star. And as I have already mentioned, we can understand the distribution and composition of the different stellar populations. That is, we can understand the structure of the galaxy. So purpose of the project is we are going to enhance accuracy of finding these final fate of stars. So this is helps in the research based organizations like ISRO and NASA. They don't want to use these in equipments to predict the functionality of the stars. They can just use the model to see and refer what it might end, and they can proceed to further researches. So this might help in small calculations and estimations. So, and then the method we have used, we have collected the data. First of all, the mass, temperature, luminosity, radius, and metallicity of the stars, which we are going to predict. We have collected the predictions, and then we are going to apply the algorithms. So, if a mass of a star is less than 1.4 the mass of the sun, it means 1.4 times the mass of the sun means it will turn into white dwarf, and same 1.4 to 2.5 means it's turned to a neutron star, and if it is 2.5 and above is it turns into a black hole. So this is what the collapse fate, we are going to predict the fate what it might happen to the star, and these are the temperature and the classifications of everything. These are the ranged classifications. We are going to put this into a condition and then predict the data accordingly, and the age is going to be predicted by its temperature and luminosity. And metallicity is a secondary factor which is also used for refining the age estimates. So it's like sharpening the age. Analyzing star mass relationship using the R directly proportional to m. So by this we are going to understand the relative size of the mass with their radius, and the host potential is going to be determined by the luminosity. luminosity and temperature also can be used, and the main factor is metallicity here. We can use to relate it to sun to determine the likelihood of planet formation in the specific star. And then this is the architecture diagram of it. So star is divided into three categories: luminosity, temperature, and mass. With the mass, we can see the lifetime and end state. End state means the collapse state, and temperature can define the spectral class and the color of the star. This is the use case diagram for implementation, and design class diagram and the sequence diagram. These are the algorithm used, metrics also used, and then the software. Very basic softwares we have used for this, and then the important code segments. This is the condition for the spectral type, and then this is the mass prediction, which the data is in the form of solar mass. So 1.4, 1.4, and 2.5 are written here, and this is the thing for estimating age. This is used as proportional, and this is the exoplanet potential. And we get the output as this. We are entering the parameters of a star, and it's predicting the stars. This is the input we are going to give, and next we receive the output: spectral type, collapse rate, age, how much age we can estimate the star might be, and the exoplanet potential. This is about a project, and these are the test cases which I've gone through, and this is the graph I have run through the test cases, and these are about my projects. And very much thank you.